And now we're being recorded for posterity. Lesson 2. In theory, this is review, but I'll assume you don't know any of it. During this scientific notation, during this course, we're going to use models, often mathematical, to help us understand a particular set of phenomena. Really, mathematics is the language of the universe. If you're good at math, you'll find this course very intuitive. If you're not good at math, you'll get much better at math because of this course. Time and time again, I've had kids come into this course and say, I'm not really good at math, Mr. Duke. And by the end, they're saying, I will push you very hard to do a lot of stuff in your head. So if you're someone who likes to do stuff in your head, you're actually going to hear me often say, look, if you can do it showing no work and go straight to your calculator and just write down your answer, I will assume you did it that way because that's how I'm going to try and teach you. On a test or a quiz, Camille, we will always show work because you don't want to make a dumb mistake. But in your homework, where you're trying to become an expert, even though I'm giving you the answers, I'm going to assume that all of you actually want to succeed in this course and aren't dumb enough just to write down the answers, copying them, and hand in the homework and, well, I did the homework. Don't do that. I will trust you to do it in as short a way as possible. And we're going to get to some fairly complicated stuff where you're going to hear me say, you know what, I think we can do this without writing anything down. We practiced enough. Let's see if we can go straight to our calculator and get the answer. But we got to walk before we can run. You will get better at math is my point. I also need to point that these models will almost always be wrong. Almost everything that I teach you is garbage, because we don't have the mathematical skills to really handle it properly. We'll ignore air resistance, for example, Braden, all the time when we're looking at free fall. And if we were designing a rocket, you would have to include air resistance. But air resistance is complicated enough that you really need calculus to analyze it. We don't have that. Or we're going to ignore a lot of stuff. But I will try and tell you when we are ignoring it. And we will be close with our work. Most of the time, we'll be pretty close anyways, so good enough. Since our models are mathematical, good math skills are helpful, but I believe physics helps you become better at math. One math skill that we're going to start out with is becoming comfortable with scientific notation. What are the rules for a correctly written number in scientific notation? There can be only one digit to the left of the decimal. So 12.3 times 10 to the fourth is or isn't in scientific notation. Is not. Why? How would I write that in scientific notation? Yes, good. 1.23 times 10 to the fifth. That's a terrible 5. My writing is horrible. If you ever can't read my writing, ask. I will never make fun of a student who asks me to translate something that I've written. It's improved over the years from illegible to only hideous. So rule 1, only one digit to the left or in front of the decimal. Rule 2, you count the number of places that you've moved the decimal point from its original location to its new location. If the decimal point moves to the left, the power of 10 will be positive. My abbrev for positive is a plus sign followed by a VE. That's the word positive. If I just see a plus sign, I'm looking for the rest of the equation. To me, that's a plus sign missing an equation. But if you want me to say the word positive, I go plus VE. I made that up. You can steal that if you want to. If the decimal point moves to the right, because we're doing small numbers, then the power of 10 will be, and there's my abbrev for negative. And then I wrote in asterisks and bold font, it is very important that you learn how your calculator handles scientific notation. I'm going to teach you, Jordan, this is how I'm learning names. I got the seating plan here if I need to look. I'm going to teach you how to use your specific calculator and do it with the fewest number of keystrokes, laziest, but also the most consistent way so that your operating system won't give you weird errors in certain situations. If you don't do it my way, you might end up with weird errors later on. Mr. Dewick, I got the same decimal as you, but my power of 10 is different from your power of 10. I know you entered the scientific notation using the wrong way. First, before you can do it on your calculator, you have to be able to do it in your head. rewrite in scientific notation, the Earth has a mass of that many kilograms, which it does. But you would never write that out. What will the first bit that I write be? If I'm writing this in scientific notation, what will I write? Okay, first thing I would do is I would go 5.98 times 10 to the. And then I'm going to count decimals. I'm low tech. I find literally with my pencil, because the decimal point is technically right there, I find drawing little loops. I'm going to count quietly. You count to yourself. If you were clever, you could probably go 3, 6, 9, count up by threes, and then just do the ones that don't quite work. 5.98 times 10 to the what? 24 kilograms. I'm really fussy on units. If in your final answer you don't put correct units, I will always take a half mark off. You'll hear me go on a unit rant later on, next lesson, I think. A proton has a charge of that many coulombs. So the SI unit for charge is coulombs. And a proton does not have a very big charge. How would I write that? First of all, what point what? 1.6 or 6.1? It's 1.6. So we're going to be consistent. We're always going to read that way, the same way we read English writing. Times 10 to the. What I do, because I know it's a small number, I prevent the subtle mistake that you just made. I always put the negative before I start counting to make sure I don't forget to put the stupid negative there, because can't tell you how many times I've forgotten to put the stupid negative there, and now I'll count. What did you get?
I got negative.
Anybody else? Yeah? And for you to enter these two numbers into your calculator, you would have to enter it in scientific notation, because unless you have a graphing calculator like Camille, not many of you have a display that will let you enter that many zeros. Okay. The temperature of the sun is 15 million degrees Kelvin. What? What? I guess, first of all, I need to take this number from English into math and then write it in scientific notation. So 15 million is going to be a 15. How many zeros make a million?
6.
And I usually put commas in. You can use commas or you can use spaces if you're typing. I'm assuming none of you are going to type up your homework, so commas. So, oh, and degrees Kelvin. So now I'm going to, by the way, that's not my final answer. So if you didn't put units there, I'm not going to freak out. Yes?
You didn't put a unit for example number 2.
So I would have lost a half mark. Thank you.
Yeah.
Because you caught me in a mistake, you get a candy. So pause for a second. 1.5 times 10 to the. Yeah, so one common mistake, especially when you're introducing scientific notation to kids, is they think, oh, you just count the zeros. No, you count the decimal places. 1, 2, 3, 4, 5, 6, 7 degrees Kelvin. So in your homework, some of the homework is going to ask you to take numbers from what we call standard form and write them in scientific notation. Or you need to be able to go from scientific notation back into standard form. So how would I write 5.4 times 10 to the negative 7? Is this going to be a really big number or a really small number?
Really small.
So the first thing I would probably do is go 0 point. That way I've taken care of that part. What's the exponent? Negative what? How many zeros am I going to draw?
6.
That's the weird thing for smaller numbers, because again, you're moving how many decimal points. So it's going to go like this. That 5 is going to be the 7th decimal point. 1, 2, 3, 4, 5, 6. 5 is the 7th decimal point, and then the 4 goes after it. And then we don't forget the units. (4.23 times 10 to the third joules. Joules is how we measure energy and work. So I write the 4. What's the exponent? So there's going to be 3 digits after this, 3 decimal locations. The 2 is the first digit. The 3 is the second digit. I need a 0. Joules. What you might often see in science, depending on how many sig figs this has, sometimes you'd put a decimal after the 0, a token decimal. Sometimes you wouldn't, but sig figs, I think, is next lesson, or the unit lesson after. Rewrite in scientific notation, that many gigawatts. Ooh. Okay. First thing that I would do, if you give me a number in standard form and a metric prefix, I would deal with the number in standard form first. I would write that in scientific notation. So that is going to be 4.06 times 10. I would put the negative in so I don't forget. 1, 2, 3, 4, 5, 6, 7, negative 8, I believe. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And then I would take care of the giga. What's giga from your formula sheet?
Big G.
Yeah, I know it's big G, but 10 to the what? Yeah. You said 9. I said yeah. 9. Yeah. It's a joke. A little German humor there? Nothing? Okay. Way over your head, right? Much like this course. 10 to the 9th. And now I can say, hey, I can use my exponent rules because those are both powers of 10. What do you do when your bases are the same and you're multiplying? What do you do with the exponents?
Add, right. Add.
Multiplying is add them. Dividing is subtracting them.
So you add.
So we would go negative 8 plus 9. This ends up being 4.06 times 10 to the 1 watts.
Wow.
No, we took care of the giga.
Yeah, but yeah.
We'll do a whole lesson on conversions coming up. I'm sneaking this in. I don't think there's any like this in your homework. Oh, by the way, the 1 is kind of optional because we understand that it's there, so I will almost never put the 1 there anymore because lazy but organized. That many, what's that little mu symbol? Micrograms. So the first thing I would do is I would take care of the number 4.2 times 10 to the,
-6.
disagree.
Well, it's 6.
I think positive 6, because this number is big. And then I would take care of the micro. Now the micro is 10 to the negative 6.
Oh, right.
You'll always, if you set these up, you'll always be multiplying. Some of the exponents will be negative, and technically a negative exponent you can write as a positive as division. Let's not bother doing that. Let's just leave them as is. In fact, I get a lovely negative 6 plus 6. And so this ends up becoming 4.2. You could write times 10 to the 0, but what's anything to the 0 power? 1. I'm fine if you just do that. So now get out your calculator. Okay. I'm going to bump up the lights in case you have solar. Need it? Here is what none of you are going to do on your calculator. And if you do it this way, I will get on you for this. If you wanted to type 6.23 times 10 to negative 5, don't write this down. None of you will type 6 decimal 2 3 times sign 1 0 exponent button negative 5. You will not. Instead, you all have a designated scientific notation button, and that button contains the times sign, the 10, and the to the power of. So first of all, write this down. In order to enter this into your calculator, you will hit the 6. Put a little box around it so you know it's a keystroke. You will hit the decimal. You will hit the 2. You will hit the 3. And then it's going to vary from calculator to calculator. Some of you will have a button that looks like that. If you have that, it's probably in the bottom row in the middle. Some of you will have a button that looks like this. If you're a TI, Camille, it's going to be second function comma or apostrophe. Okay? Some of you might have a button that goes EXP. If you have that button, it's either right above the number 7 or in the bottom row in the middle. The button you do not want to use, don't do that. So, this is your chance to find your scientific notation button. You'll put that button right there, and then you can hit the negative and the 5. I'm going to pause the video, and I'm going to come around, and you're going to show me your scientific notation button. So the reason you use that button, whatever it is if you use that button, your calculator knows that this and this are connected, and it will treat them like one number. In other words, if you want to square this number and you use your scientific notation button, you can just put a square there without having to put the whole thing in brackets. Or if you want to divide by this number, you can just divide by that number without having to put the whole thing in brackets. And you also want to notice how your calculator displays scientific notation. So some of you, when you press this button, you actually see a little times and a 10 to the. On the graphing calculators, all you see is a shrunken down little capital E. And that's because those aren't calculators. Those TIs are actually considered computers. And on a computer, that's how you would display scientific notation back in the MS-DOS days. It's left over. It's a legacy thing. Who had the really cheap TI yesterday? Or did you bring it? Okay, but you brought a different one? The same one? Yours, I think, just puts a space in and expects you to clue in that that's scientific notation. So you might see that yours might do this, 6.23. And you're expected to clue in that that little space there means scientific notation. One of the reasons I can't stand that calculator. Anyways. So all of you type that in. I will do it on my calculator. By the way, somebody was telling me that they had the identical calculator to me, and I argued with them, and I said, no, you don't. I have the apps button. You don't have the apps button. I told you you didn't have the same calculator as me. Nice try. 6.23, the blue button right there. Right there. You don't have it. Told you. You have the older model. So for me, I go 6.23 scientific notation, -5. Type it in and then hit enter or equals or whatever, the bottom right key. My calculator gives this back to me in scientific notation. Some of your calculators might have converted it to standard form. So some of your calculators might be saying 0.0000623, 4 zeros, and then a 6 and a 2 and a 3. It's going to vary. Some of your calculators, when it displays scientific notation, is a function of the operating system, but you can change that. And if you, over the next few days, want to, I can dive into it with your calculator, and you can customize how you want your calculator to display. I told you yesterday, I'm going to teach you how to make your calculators sing. So, next page, let's try some. It told me that you entered it correctly. That was step one. Okay? So turn the page. We're going to do some calculations. First of all, example 1, is this a fraction?
Yes.
Is there more than one thing on the top?
Yes.
We're going to either have to put brackets around the top, or those of you that have the newer calculators that have that button, which is usually on the left side, second or third button down, you can do a 2-level fraction, which is much nicer. You don't have to put the top in brackets. But those of us that don't have the newer calculators, we're going to have to put the top in brackets. Don't start typing yet. We're going to type this key by key, because I'm going to show you how to type this with the minimum typing and maximum organization. So don't work ahead. Here is what we will type. Get your calculator out. If you have the fancy schmancy fraction button, hit that. Those of us that don't, we're going to open a bracket. Find an open bracket, which is probably above the 8 and the 9. Probably. Okay? Yours, go hunt for it. And the nice thing is mine displays a bracket. I don't know if yours does. Sorry, Braden. Yeah. Again, you can totally get through this course with that. If you want, go ahead. I'm going to type 1.8. I'm not going to hit times. I'm not going to type 10. I'm not going to go to the power of. I'm going to hit my scientific notation button, whatever yours is. Then we have to distinguish between a negative and subtraction. All of your calculators have a different button for subtraction versus negative. So this is -3. You'll notice I didn't hit my times 10 to the or anything like that. I'm not going to close off a bracket yet because we're still on the top. What do these two brackets right here side by side mean?
Multiply.
I think it's way easier to just put a times there. When I handwrite, I'll show multiplication with brackets, but Spencer, when I type on my calculator, too many brackets gets too confusing. I'll show you how some of you might have wanted to type it in just a second, and I'll argue my way is way clearer. Then I'm going to go 2.6, scientific notation button, 5. I've reached the end of the top. I'm going to close off the top. Those of you that have the fancy schmancy 2-level fraction button, you'll just go down arrow. Is there more than one thing on the bottom? Brackets around the bottom. Open up a new bracket. Oh, sorry. I got to go divided by. Duh. And then brackets around the bottom. 9. Scientific notation button. 8. I have two brackets side by side. What does two brackets side by side mean? I'm going to go times. 1.3. Scientific notation button. -1.
What's the exponent for the 9 times?
I don't know. What is it on your piece of paper? 8. Then I close off the bottom. If you hit equals, you should get either 4 times 10 to the -6, like I did, or your calculator might display it as 0.000004, 5 zeros and a 4. I did this on purpose because this is right on the tipping point for most of your calculators when they flip from scientific notation to numerical display. So you either have something that you can interpret as 4 times 10 to the -6, or yours says 0.000005 5 zeros and a 4. Yes?
Wait, so when you enter this though, let's go 1.8 times 10 to the -3, be multiplied by 3.6 and then multiplied by 10.
It was. My calculator did all that for me. I have a good calculator. It knows bad mess if I type it incorrectly. Okay, don't clear your calculator. I'm going to come. First of all, if you didn't get that, what you want to do is raise your hand. Don't clear your calculator, and I'll come look over your shoulder. Some of you might like to show multiplication with brackets. First of all, I'm going to argue the way I typed it. Now, I have a 2-line display, but I'm going to argue that's fairly clear. It's fairly clear that that's on the top divided by, and that's on the bottom. If you like to show timesing with brackets instead of a times sign, here is how you would have had to have typed this. Double bracket, 1.8, scientific notation, -3. Close it off, open up a new bracket, 2.6. Scientific notation, 5. Close that off, close off the top, divided by, double bracket, 9. Scientific notation, 8. Close that off, open up a bracket, 1.3. Scientific notation, -1. Close that off, close that off. I get the same answer, but look up which of those is easier to read. I think the first one. So those of you that like to show multiplication as brackets, I'm going to try and break you of that habit because you're doing more typing for less easy to read. That's double yuck for me. Okay? Let's try the next one. Oh, 4 times 10 to the -6 and no units. Example 2. Is this a fraction?
Yeah.
Is there more than one thing on the top?
Yeah.
I'm either going to have to open up a bracket, or if you have the fancy schmancy 2-line fraction display, hit that button. So for me, open up a bracket. Actually, you know what I should do before I do that, Mr. Duick? Clever boy. Okay, I botched that. Let's try that again. Bring that line back, bring that line back, bring that line back, bring that line back, hit equals, and then I can go like this. There.
That is crazy.
Now the calculator's in the lesson. So, ready? Let's start with the second one. Open up a bracket. 5.8. I'm not going to hit times 10 to the, I'm going to use my fancy schmancy scientific notation button. 3. Instead of 2 brackets showing multiply, I'm just going to hit multiply because that's easier to read on my calculator. 2.67, scientific notation, 21. Close off the top. Divided by, open up a bracket. Probably right now, a lot of you are sitting on that weird exponent if you've worked ahead. So -9.24, scientific notation, -3, and I want that whole thing to the 5th power. You'll notice because I use scientific notation, I didn't need to put this in its own little mini bracket. How do I do exponents? Okay. Most of you have a button that probably looks like a little hat on your computer keyboard, Shift-6. It's the carré, I think it's called. That's going to be your exponent button. Some of you might have an X to the Y button. Some of you might have a Y to the X button. You've got something really cheap and weird, but I'll look at yours in a second. So your job right now is to try and find your to the power of button and see if you can figure out how to enter that. I'll pause the video and come around. Continue. Times 1.3. Scientific notation button, -1. Close off the bottom unless you have the 2-level fraction thingy. Is that right? -1.76862617 times 10 to the 36th power?
I got something.
So if you did not get that, don't clear your calculator.
I got
First of all, it should be negative. So how many decimals do I write? Well, it turns out there are rules for rounding off. It's called sig figs. I haven't taught you those rules yet. Some of you may have come across them if you took Chem 11 already. I'm going to go 1.77, negative, sorry. 1.77 times 10 to the 36th. Okay? Now, If you didn't get that, I'll come around and help you in just a second. But for now, you can try the lesson 2 homework. It also says sheet scientific notation practice. I skipped that. I didn't bother photocopying that. So here is the homework, and I believe, I attached the answers on the last page, so you can do this right on this sheet if you wish to. If you're someone who has to do homework on a separate piece of paper, go ahead. I'm fine with that. I really don't care. All I care about is that you learn. So if you want to, you can write right on here. If you want to, you can do it on a piece of paper. And where do we hand stuff in? So when you are done, you can hand it in. You probably will get it done in class if you medium hustle, and if I don't distract you too much, which I will. So start the homework, and I have some videos for you either later on or we'll get to them next class.